Welcome recruits to Phase 7, Part 1 of AP Calculus Bootcamp, Operation Signal and Reconnaissance. Your clearance is verified for recruit eyes only. Today's briefing covers topics 7.1 through 7.4 of differential equations, representing a critical 6 to 12% of your AP Calculus AB exam. Status is Mission Go. Here is your sitrep on the nature of our new target. In the past, standard algebraic equations yielded a static numerical value. Differential equations, however, yield an entire function or family of functions designed to model dynamic rates of change. Your objective is to translate real-world intel into differential syntax, map their behavior visually, and authenticate candidate solutions. We begin Phase 1, Signal Interception for Topic 7.1. You must translate verbal raw intel into mathematical directives. The keyword phrase rate of change is your decryption filter for a derivative, such as dp dt. The phrase is proportional to dictates a constant multiplier, k. Combine these to form your mathematical directive. dp dt is equal to kp. Maintain situational awareness regarding variable versatility. Standard issue uses x and y, but field operations require adapting to population intel like dpdt or network data like dcdt. Do not let alternative letters disrupt your operational procedures. Identify your independent and dependent variables before engaging. The core logic hub remains identical. Moving to Phase 2, Target Authentication for Topic 7.2. To verify a candidate solution, we use a closed-loop verification system. First, run the candidate through a differentiator. Then, inject both the candidate function and its newly calculated derivative back into the given differential equation. If the proving ground balances, if the left side exactly equals the right, the candidate is authenticated as a valid solution. Intel update on solution types. A general solution contains the unknown variable plus c. This represents an infinite fleet of trajectories, varying only by a constant of integration. A particular solution uses an initial condition, a specific coordinate drop, to isolate a unique target trajectory from that fleet, locking in the exact value of c. Phase 3 initiates visual reconnaissance using slope fields for Topic 7.3. A slope field is a graphical representation of a differential equation evaluated at a finite set of points. They reveal the hidden currents of the coordinate plane. Any dropped initial condition will be swept along these lines. Warning: they only provide visual behavior estimates for first-order differential equations, not exact algebraic solutions. Here is your standard operating procedure for generating a slope field. Step 1. Coordinate acquisition. Identify your target input point. Step 2. The equation engine. Plug those coordinates directly into the given differential equation. Step 3. Slope output. Compute the resulting numerical slope value. Step 4. Vector rendering. Sketch a strictly angled line segment at that exact coordinate location. You must master the pattern recognition matrix to match visual intel with algebraic equations. Look for horizontal zero slopes. If they occur along the x-axis where y equals 0, then y must be in the numerator of the differential equation. Look for vertical undefined slopes. This indicates a variable is in the denominator causing a division by 0. If you see identical parallel columns, the equation relies purely on the independent variable, x. We have authorization for direct recon bypass protocols. If a mission request simply asks to find the slope at a specific point, do not execute a full integration campaign. Avoid separating variables or solving for c. Instead, bypass the algebra and plug the given coordinates directly into the given differential equation, dy dx, to instantly extract the slope. True mastery requires target triangulation. You must recognize that verbal intel, algebraic equations, and visual slope fields are three representations of one unified mathematical reality. A successful agent can seamlessly translate a verbal rate of change into a differential equation and then map that equation to its visual slope field counterpart. Time for the after-action report. Let's debrief Phase 7, Part 1. 1. The goal is to find a function modeling a dynamic rate, not a static number. 2. Transcribe verbal intel meticulously into derivatives. 3. Authenticate candidate solutions by differentiating and substituting. 4. Slope fields reveal the visual flow of function families. 5. Use the bypass protocol to find slopes directly. Next phase, analytical solutions. Status: dismissed. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.